When you look up at a cloud, what do you see? Probably something light, fluffy, almost, well, weightless, right? It looks like you could just reach out and punch a hole right through it. But you know what? Today, we're going to completely change how you see them. Okay, let's just dive right in. Take a look at this cloud. A pretty standard, puffy cumulus cloud. Looks like a big piece of cotton candy floating in the sky. But what if I told you it's hiding a secret? A very, very heavy secret. Get this. That cloud weighs around 500,000 kilograms. That's 500 metric tons. I know. That number just seems totally impossible when you're watching it drift so lazily across the sky. To really wrap your head around that, imagine about 100 adult elephants. That's the same weight. Which, of course, brings up a pretty big question. How on earth can something that heavy just float? That is the $1,000,000, or I guess the 100 elephant question, and that's exactly what we're going to figure out. We're going to unpack the physics behind this seemingly impossible fact. So the secret isn't some kind of magic. Nope. It's actually hidden in the very stuff that makes up the cloud itself. It all comes down to something microscopic, and there are trillions and trillions of them. And here is the first major clue. A cloud isn't one solid object. It's actually a giant collection of tiny, tiny water droplets or ice crystals. And I don't mean millions, I mean billions, or even trillions of these little guys, all hanging out together in the air. By itself, each one of these droplets is practically weightless. I mean, they're so small, their diameter is measured in millionths of a meter. But when you get trillions of those almost nothings together, well, their combined weight adds up to something truly massive. It's the ultimate example of strength in numbers. So how do they all get up there? It's a process we all learned in school, right? Water on the ground, from oceans, lakes, you name it, evaporates and rises as vapor. As it gets higher, it gets colder, and it condenses around tiny particles like dust. Every single one of those trillions of droplets in our 100 elephant cloud started out this way. Okay, so the cloud is super heavy because it's stuffed with trillions of droplets. Got it. But that still leaves us with the biggest mystery. Why doesn't it just plummet to the ground? Well, the answer is a constant, invisible battle against a force we all know very well, gravity. It really just comes down to two opposing forces. On one side, you've got gravity, constantly pulling every single one of those droplets down towards the Earth. But fighting back, you've got this powerful upward force, currents of rising warm air called updrafts. And here's the kicker. A cloud just floats there as long as that upward push from the warm air is stronger than gravity's downward pull. It's this enormous, delicate tug of war happening miles and miles above our heads. Pretty cool, right? But that balance can't last forever. So what happens when it gets disrupted? What happens when that cloud finally gets too heavy for the updrafts to hold it? Well, that's when we get something we're all very familiar with. So what's the tipping point? Inside that cloud, all those tiny droplets are constantly bumping into each other and merging, growing bigger and heavier. And eventually, they get so big that the updrafts just can't hold them up anymore. Gravity finally wins the tug of war, and the droplets start to fall. And that fall is what we call precipitation. You know it as rain, or depending on the temperature, it could be snow, sleet, or even hail. It's literally the cloud letting go of all the water it just can't carry anymore. So, fine. Clouds are heavy, they float, and then they make rain. But why does any of this matter beyond whether or not you need an umbrella? Because it turns out these clouds are way more than just floating water. They are massive engines that help run our entire planet's climate. You know, it's kind of wild. Clouds play this fascinating double-agent role. During the day, their bright white tops are like giant mirrors, reflecting sunlight back into space, which helps cool the planet down. But at night, they can act like a blanket, trapping the heat rising from the Earth, which has a warming effect. It's another incredible balancing act. And their impact is absolutely global. Think of these heavy clouds as a planet-wide delivery service. They move enormous amounts of water around, sustaining ecosystems and refilling our rivers. They are literally the architects of our weather patterns. And understanding their weight, that's totally crucial for forecasting everything from a light shower to a massive hurricane. There's this quote that just nails it, perfectly summing up this whole thing. It really gets to the heart of it all.
Our whole idea of clouds being these lightweight, flimsy things is really just an illusion caused by distance.
So, really, it's all about changing our perspective. A cloud isn't just some empty space with a bit of fluff in it. It's a massive, floating reservoir of water, a critical piece of the giant engine that makes life on this planet possible. So, the next time you look up and see a cloud drifting by, maybe you won't just see a fluffy shape anymore. Maybe, just maybe, you'll see 100 elephants worth of water hanging in the sky in this delicate dance against gravity, one of the most powerful and essential engines of our world.